Well, this is Unit 2C, Part 2, and we're going to start with Question 4. How do you measure 6 minutes with a 7-minute hourglass and a 5-minute hourglass? Assuming that the hourglasses can only measure 7-minute and 5-minute intervals, respectively, and cannot be used to measure other time intervals. Well, let's do this with a chart. So I'll call it F for flips. And we've got the 7-minute and the 5-minute hourglasses, and then we'll have a difference. And what we'll do, we'll flip the two glasses over simultaneously, and as soon as one runs out, we'll tip them over and stop the drain on the other, and we'll have minutes remaining. And we'll repeatedly do that and find the difference each time. So first flip, when 5 minutes is empty, we'll have 2 minutes left in the 7-minute hourglass, so the difference is 2. Now let's flip them both again. When the 7-minute hourglass runs out, 2 away from 5 is 3 minutes, so we'll have a 3-minute difference. Now let's flip again. And when we flip this, the 3 minutes will run out, and so 7 minutes minus 3 minutes is 4 minutes, and our difference will be 4. So for 4, now we'll flip them both again, and when this runs empty, we'll have 5 minutes minus 4 minutes, 1 minute remaining, and the difference is 1. Now for the 5th flip, we'll have 7 minutes of sand in this hourglass. We're going to have 1 minute at the top, so we're going to flip them both. When this 1 minute runs out, we're going to have 6 minutes left, and there's our difference of 6, and notice that's what we wanted. We measured, we have a 6-minute measure in the 7-minute hourglass, and there's the process by which we got it. Okay, number 5, you are considering buying 15 silver coins. Well, let's get rid of this. 15 silver coins that look alike, but you have been told that one of the coins is a lightweight counterfeit. How can you determine the lightweight coin on a maximum of 3 weighings on a balanced scale? Well, let's break these 3 coins up into groups of 5. So 5, 5, and 5. And will you agree that if we put these two on a balanced scale and they both they balance, then the light coin's here. On the other hand, what if you put these two on a balanced scale and one of these is heavier than the other? Then we've identified the column with, or the 5 coins containing the light coin. So given that, so this is W for weigh 1. So weigh 2. Now we're going to take this column of 5 that contains the light coin. We're going to break it up into 2, 2, and 1. 1, 2, and 2. Will you agree if these two are balanced on the scale, then this is the light coin? On the other hand, what if these two are not balanced? In fact, if that's a light coin, we're done right there. On the other hand, what if these two are not balanced. And therefore we can pick the column with the lighter coin in it. And for the third weighing, we'll weigh 1 and 1, and we will identify the light coin in that manner, and we're done with that one. So for number 6, a father and son are in a terrible car accident. The father is killed. Oh. The son, badly injured, is brought to the hospital for emergency surgery. The surgeon takes one look at the patient and exclaims, "That's my son. How is this possible?" Well, the surgeon must be the boy's mother. That's how it's possible. So, here we have one more. Paul and Saul. So, Paul and Saul ran a 50-meter race. When Paul crossed the finish line, Saul ran only 48 meters. Then they ran a second race with Paul starting 2 meters behind and the starting line. Assuming that both runners ran at the same pace as in the first race, who won the second race? Well, first of all, we know this. Rate times time equals distance. And we're talking about Paul and Saul. And the times are identical. Paul ran 50 meters when Saul ran 48. And so rate then equals distance divided by time. So Paul's rate is 50 divided by t. Saul's rate is 48 divided by t. Now, they ran a second race, and they ran at the same rates. And so 50 divided by t and 48 divided by t, except this time Paul had to cover 2 more meters, so he went 52 meters and Saul went 50 meters. And the question is, well, what are their times? If we knew who had the shorter time, then we would know who won the race. So, and by also, t equals distance divided by rate. So this is the time for Paul, t sub p. This is the time for Saul. So the time for Paul equals, let's see, distance 52 divided by 50 over t. Will invert and multiply, and so the t will go up here. And if you run that through a calculator, what you get is 1.04 t. Now the distance time for Saul is 50 over 50 over 48 over t. Will invert and multiply, and that t will go upstairs. If you run that through a calculator, what you get is 1.042 t, rounding up. And so the shorter time is associated with Paul, so Paul won the second race, and we'll stop here.